The most important part of any software is data. To manage that data, you need to able to insert new data into the database, retrieve existing data, update current entries, and remove unnecessary data. These tasks are often called CRUD operations: create, read, update, and delete. In this video, I am going to show you exactly how to perform these CRUD operations in your application. Let's check the final demo. This is our home page. Here you can see the list of entries. We can add new entry by clicking this add new button. Here, fill up the form, first name, last name, provide an email, and finally a dummy phone number. We have also added validation here. If we submit this data, you see we have an error in email field. Now provide a valid email address. Submit. Here is our new entry is inserted. Here is our new customer. We can view individual customer data by clicking the show button. Here is the individual customer data. Back to the home page. We can also update the entry by clicking the update button. This is the update form. We can update the necessary information and submit. Our customer entry is updated. And finally, if we want to delete the customer, we can click this delete button. Here we have a message that the customer is deleted and the customer is no longer in this table. That's what we are going to learn. Let's get started. I am going to create the project from scratch. To create a new project, I will use my favorite online Spring initializer tool. Head over to start.spring.io. From here, we can generate our Spring Boot project. I will use Maven as my dependency management tool. My primary programming language is Java. For the Spring Boot version, at the time of this recording, the latest version is 3.3.5. Always choose to use the latest version of Spring. For what I am going to teach you in this tutorial, Spring Boot version 3 is the minimum required version. Now, let's change some metadata. Here, for the group, I am entering my domain name, com.learnwithiftekhar. Then, in the artifact, I am providing the name of our project, Spring Boot CRUD. Let's give a short description of the project. For the packaging, I am going to select jar. And for the Java version, the minimum required version for Spring Boot 3 is Java 17. So, I am going to select that. If you are using Java version newer than 17, you can go with that. The code I will show you in this tutorial is compatible with the latest Java versions newer than Java 17. Now, it's time to add the necessary dependencies. The first dependency I need is Spring Web. Then we need Spring Data JPA for database operations. I am going to use MySQL database, so we need a MySQL driver as well. Since we will working with views, let's add Thymeleaf as a dependency. And also, I will do some validation. That's all the dependencies I need for now. If I need any other dependencies in the future, I will add them in the project later. Now, let's generate the project. Click on this generate button. Our project is generated and downloaded as a zip file. Go ahead, unzip the project and import it into your favorite IDE. Here, I have imported the project into my IDE. I am using IntelliJ IDEA Ultimate version. If you are using Spring Toolsuite, Eclipse or NetBeans or any other IDE that you are comfortable with, go with that. The IDE is just a tool. Use whatever IDE you are comfortable with, but make sure you know how to compile and build your code. Now, let's have a quick look at the file and folder structure of the project. The first file I am going to show you is pom.xml. POM stands for Project Object Model. This is the file that contains the necessary information about the project. Here is a Spring Boot version. Then we have the project metadata that we defined earlier while creating the project. This is the group name, the artifact ID, and the name of the project. Here is the short one-line description that we provided about the project. Then we have the dependency section. Here all the dependencies are defined. This is the dependency for Spring Data JPA, Thymeleaf, which we will use for our view templates, Spring Boot starter validation. This dependency helps to validate the submitted form data. This one is Spring Boot starter web, MySQL connector, which is basically the MySQL driver. Then we have Spring Boot starter test. This dependency is added by default. Let's close this POM file. Next, we have this src folder. Inside these, we have two subdirectories, main and test. All the test files that we write for testing the application will go to the test directory. Our main source code will go into the main directory. Let's expand this. Here we have two subdirectories, Java and resources. We will put all the Java code inside the Java directory. Let's expand the resources directory. This directory contains the application.properties file and two more subdirectories, static and templates. The static directory contains static resources like images, CSS and JavaScript files. The templates directory holds the Thymeleaf templates, which are our HTML files. And this application.properties file holds the necessary configuration of the application, like our database credentials, OAuth or server settings. Now let's start the project. You can run the project by clicking this play icon at the top. Here is the console. Let's resize it. Our application failed to start. Let's check what the reason is. Failed to configure data source. URL attribute is not specified and no embedded data source could be configured. So, what is the problem? In our project, we have included Spring Data JPA as a dependency. This requires you to configure your application to connect with a database, but we have not done that yet. So, Spring is throwing this error. Let's configure our application to connect with the database. Now, let's create a schema in the database. I have already MySQL database installed in my machine. To access the database and create a schema, you can use the command line if you are comfortable with that. Or you can use a GUI tool like MySQL Workbench to connect with your MySQL database. Here, since I am using IntelliJ IDEA Ultimate version, it comes with a database too. So, I can use it as a GUI tool for accessing the database. Just click on this database icon on the left. To add the database, click on this plus icon. Select data source, search for MySQL, select that. In this window, we need to provide the connection details of our database. Here, we need to provide the server address. My database is running on localhost. Then the port, I am using the default port, that is 3306. Here, I am providing my database username, providing the password. Now, click on test connection to check if we make successful connection to the database from the IDE. This time the connection was successful. Click OK. Here the connection is shown in this panel. A database console is opened in the IDE. You can write SQL statement here. Now I need to create a schema. Right click on this connection, select new, then schema, provide the schema name, let's say Spring_CRUD. Click OK. Here our schema is created. Currently it does not have any table. We need to create those. Now, instead of creating the tables manually, I am going to use JPA features to create the database and necessary columns. But if you are using this in production, you may have already created those tables. In that case, you may need to alter your tables by yourself. I am not going to demonstrate that in this video tutorial. Instead, I am going to use the JPA feature that can create or alter the tables. Now, our schema is created. Let's configure our Spring Boot application to connect with this database. Closing the database tool, closing other tabs. Now we need to provide the database credentials in the application.properties file. Let's rename this to application.yml. I am comfortable with YML markup. That's why I am using it. If you want to use application.properties, you can do that too. We don't need this. Next, providing our database configuration. Spring, data source, URL. For MySQL, our URL is jdbc:, MySQL:, then // then the database server address. I am running my database in my localhost, then the port. The default port for MySQL is 3306, then / and database name, Spring_CRUD. Next, we need to provide the username. On the next line, type username and my database username is root. Next, provide the database password. Here, I am providing my database password. Now, let's start the application. This time, the application started successfully on port 8080. So, we have configured our database successfully. Beside those basic configurations of the database in the application, I want to specify some additional configurations for how Hibernate should manage the database schema. So, let's add Spring JPA properties. Under Spring, add JPA -net dtl-auto update. Here, pay close attention to the indentation. It is important. If you provide the wrong indentation, it will not work. Here, this JPA is a direct child of Spring. -net is a child of JPA. You need to indent it accordingly. And so is DDL auto. Here I am setting it to update. This DDL auto controls how -net will handle our database schema. Setting DDL auto to update means that -net will automatically create any new tables or column in the database based on our entity class. But it won't delete or modify any existing data. This is super convenient for development, where we often make changes to our entities and want those changes to reflect in the database without manually updating the schema. Now, let me explain other options provided by DDL Auto. This one is validate. This only checks the schema matches our entities. If it does not, the application won't start. Then we have create. If we choose this option, it will drop and recreate the database schema every time the application starts, which can be useful for testing, but it also means any data will be lost on restart. Then we have create drop. This one is similar to create, but it also drops the schema when the app stops, ensuring a clean database every time. So, by using update, we are telling -net to take care of the schema updates without touching any existing data. It's a good balance for development, but not something we would use in the production. I also want to see the SQL queries, so let's include that option. Under Spring JPA, add show_SQL and set it to true. Make sure the indentation of show SQL is the same as the indentation of -net here. Also, I want to see the queries properly formatted. To configure this, properties -net format_SQL and set the value to true. That's all for our database configuration. Finally, another property we need, that is database platform. Set it to org.hibernate.dialect.mysql8 dialect. Here I am using MySQL 8 dialect because I am using MySQL version 8. Now let's start the application. Our application has started on port 8080. Let's try to access it. Open your browser and go to localhost, then port number is 8080. So we get this white label error page. The error code is 404, which means not found. That's because we have configured our database but have not configured our application to handle the URL. Let's fix it. Back to the IDE. To handle the HTTP request, we need to create a controller. In our project, under src main java, this is our base package. Inside this, I am going to create a new package for controllers. So right click on the base package, select new package, give it a name. In my case, I will name it controller. Inside this controller package, create a new Java class. Right click, new Java class, give it a name. Let's say home controller. If you are using IntelliJ IDEA, make sure you choose class from the options. Press return if you are on Mac or enter if you are on Windows. Our home controller is created. Spring uses controllers to handle HTTP request. To tell Spring that this is a controller, we need to annotate it with controller. Make sure to import controller from org.springframework.stereotype. Next, we need to create a method that will handle the HTTP request. Let's define a public method with a return type of string and name it home. This method will be responsible for handling HTTP request from the root URL and will return a HTML page. Let's say the name of our HTML page is home. To tell Spring to map the root URL to this method, we need to annotate it with get mapping. I'm using get mapping because it will handle get request. If you have a method that will handle post request, you can use post mapping. We will explore it later in this video. Back to the get mapping. Inside the parentheses, we need to provide the URL. Since this is our root URL, we'll leave it empty or specify root. Now we need to create the home.html file. Inside src main resources, go to the templates folder, create a new HTML file, name it home. Let's change the title and add a header. In the HTML file, set the title to home page. add a h1 header, hello from home page. Now let's restart the application again. Go to the browser, refresh the page at localhost 8080. Here Spring is presenting our HTML page. Now let's make this view dynamic. Let's say we want to pass a query string parameter name and display its value on this page. To do this, back to the IDE. In the home controller, in the home method, we need to accept the request parameter passed using the URL. So we'll use the request param annotation. We will use the request param annotation from WordG Spring Framework Web Bind annotation. Inside the parentheses, we specify the value. Our value is name, the name of the parameter, the default value, setting the default value to an empty string. Now declare the data type. This is of type string. We also need another object model to pass data to template. Make sure you import model from WordG Spring Framework UI package. Now inside the method, let's say we want to show hello followed by the name. So create a new variable, string, say hello equals, provide the string hello and concat with the variable name. Now we need to add this to the model. Add a model attribute, model dot add attribute. Let's say our attribute name is message and pass our variable name. Say hello. Finally, return the name of the HTML template. Now open home.html. To display the variable provided from the controller in this HTML page, we need to do some additional setup. Let's check the Thymeleaf documentation. In your browser, search for Thymeleaf. This is the official Thymeleaf website. Go to that site. Now go to the docs. Under using Thymeleaf, select the latest version, which is at the time of this recording, Thymeleaf version 3.1. Click on read online. This is a documentation of Thymeleaf. Feel free to explore it yourself. I am going to the section using text. Here you can see an HTML code sample. Check the HTML tag. Here we have a special namespace declaration. This is specific to Thymeleaf. We need this declaration to show variables in the HTML page that are provided by the controller. Let's copy this. Now back to the IDE. In the home.html file, in the HTML tag, paste the code. Now our HTML is ready to show the value of the provided variable. After the h1 heading, add a new h2 heading. We are going to display the message here. To do this, inside the h2 tag, before the closing angle bracket, type th:, we want to show text equals, then the $sign, then curly braces. This tells Thymeleaf that we are providing a variable. So Thymeleaf will replace the variable name with the value of the variable. Now between the curly braces, provide the variable. That is our model attribute that we have declared earlier, message. This tells Thymeleaf to display the value of the message variable provided from the controller. Now restart the application. Go to the localhost 8080. Here we are just seeing hello. Let's add a query parameter in the URL. In the URL, type name equals my name, Iftekhar. Now it's displaying hello Iftekhar. So we have successfully displayed the text provided from the controller. Now let's start coding for CRUD operations. On our home page, I want to display data from the database. For database operations, we need an entity that maps Java object to database tables and columns, a repository for performing database operations, and an optional service layer for implementing business logic. Let's start with the entity. Opening the sidebar, in our base package, create a new package. Right click on the base package, new package. Give it a name, let's say it's model. We will put all of our entity classes inside this package. Now in the model package, create a new Java class. Right click on the model package, new Java class, name it customer. Our customer class is created. So far, this is a plain Java class. To make it an entity, we need to annotate it with entity. Optionally, you can give this entity a specific name. If you don't provide a name, Spring Data JPA will use the class name as the entity name. Next, let's map it to a database table. Annotate it with table. Provide the name of the database table that we want this entity to map to. In our case, it's customer. Here, my IDE is showing an error. The reason is that the entity needs to have a primary key. Let's define it. Create a private field, data type long, field name is ID. To make it primary key, we need to annotate it with ID. Now, we need to define how this ID will be generated. There are a couple of options. First one, manually assign the value. We would have to set the ID ourselves before saving the data. Another one is automatically generate it. Let the database generate ID for us. I want to generate it automatically. So, we need to use the generated value annotation. Now, tell Spring Data JPA how to generate the value. Inside the parentheses, we need to provide the strategy. There are a couple of options. The generation type can be auto, identity, sequence, table, or UUID. If you are using MySQL and want to use MySQL's auto increment feature, you can choose identity. I am going to use generation type identity here. So, update the ID field. We can also define the column name using the column annotation. Provide the name of the database column you want to map it to. I want to map it with the same name as the field, which is ID. Now, let's add another properties of our customers. Our customers will have first name, last name, email, and phone number. Here, we can define a column for each of the fields. If we do not define anything, Spring Data JPA will consider the field name as the column name and map it to the database table. For field names that use the camel case formatting, it will add an underscore between the words to generate the column name. For example, first name becomes first underscore name. Now, let's define the column names explicitly with the column annotation. For first name, first underscore name. Now for the last name, the column is last underscore name. For email, since the field name matches the column name, we can leave it as it is or explicitly annotate it. I am going to annotate it. Column name is email. For the phone number, the column name is phone underscore number. Now we need to generate the getters and setters. Let's generate them. Right click inside the class, generate getter and setter. Select all the fields and click OK. Our getters and setters are generated. Now let's run the project. In the console, you can see the SQL query printed. It has created the customer table. If you check the database, expanding the database tool, here this is our schema. Let's expand it. Here it is showing nothing. Let's refresh. Click on this refresh icon. Now we have this table. Expand it. Here is our customer table. Here is our columns, ID, email, first name, last name, and phone. You should see the customers table with the columns we defined. Based on our customer entity class, Spring Data JPA has created the table with the necessary columns in the database. Now, we need a repository to interact with the database. Let's talk about the repository pattern. It's a design pattern that connects data access and business logic in our application. By using this pattern, we can abstract the data layer, providing more object-oriented way to access data. In Spring, we use repository interface to interact with the database, leveraging the powerful features of Spring Data JPA. At its core, the repository pattern acts as a bridge between the application's business logic and data storage. It encapsulates data access logic within the repositories, which are responsible for querying and manipulating the data from the underlying data source, like a database or a web service. By doing this, it shields our application from the complexities of data storage. This makes it easier to switch between data source or make changes to the database schema without affecting our application's code. The repository interacts with the data mappers and query objects to perform operations like retrieving and saving data. Even though it might seem like overkill for our simple app, using the repository pattern provides a protective layer that ensures our application can scale effectively and handle more complex scenarios in the future. Our repository pattern allows our business logic to query and parse data without needing to know the details of the underlying database operations. It promotes cleaner and more manageable code. Let's dive into our code and build this together. Let's create our repository. In our base package, create a new package. Right click on the base package, new package, name it repository. Now create a new interface inside the repository package. Right click on the repository package, new Java class. In the dialog, make sure to select interface instead of class. Give it a name, customer repository. Press enter or return if you are using Mac. Our customer repository interface is created. To let Spring Boot understand that this is our repository, we need to extend CRUD repository. This interface provides all the necessary methods for performing CRUD operations, so we can proceed with minimal code. Let's take a moment to understand what CRUD repository provides. CRUD repository is a generic interface, which means we need to specify two parameters inside the angle brackets. The first parameter is the entity class we are working with. In our case, it's customer. The second parameter is the data type of the primary key of our entity. For our customer entity, the primary key is ID, which is of type long. Let's check the source code of CRUD repository to see what methods are available. Hold Ctrl or Command on Mac and click CRUD repository. It will open the source code of CRUD repository interface. Click here to download the source. Here you can see that CRUD repository provides several methods for basic CRUD operations. Save for saving an entity, find by ID, retrieve an entity by ID. Then we have find all. This method is used to get all the entities from the database. And here we have delete by ID, delete an entity by its ID, and many more. These methods allow us to interact with the database without writing any SQL queries. Returning to our customer repository, since we have specified customer as the entity and long as the ID type, our repository is now ready to interact with the database. Now we need to add a service layer. The service layer is an important part of the application architecture that handles business logic and ensures a clean separation of concerns. It acts as intermediary between the controller and the repository layers. Why add a service layer? By separating our code into layers, we keep our controllers lean and focused on handling HTTP requests. The service layer manages the business rules, validations, and complex operations. This separation allows for better organization and makes our code more maintainable. Let's visualize our application architecture. At the top, we have the controller which handles incoming HTTP requests. The controller passes those requests to the service layer where all the business logic and complex operations happen. The service layer then communicates with the repository, which interacts directly with the database. This separation keeps our controllers clean and focused, while the service layer manages the business rules, making our code more organized and maintainable. Now, let's implement the service layer together. Creating the service package. In our base package, right-click, New Package. Name the package is Service. Create the customer service class. Inside the service package, create a new Java class. Right-click on the service package, New Java class, name it Customer Service. Open customerservice.java. At the top of the class, add the service annotation to let Spring know this is a service component. Now, we need to inject the customer repository into our service so we can interact with the database. Let's do this step by step while coding in our IDE. First, in the customer service class, we need to create a new private field for the repository. Here I am declaring a private field of type customer repository and naming it customer repository. The final keyword indicates that this field will be assigned once and won't change. Now we need to inject this repository into our service. In the past, we might have used the auto-wait annotation for dependency injection. While using auto-wait still works, it's no longer the recommended approach. You might wonder why. Well, explaining this in detail would take some time and is a bit beyond the scope of this tutorial. If you are interested in learning more about this, I have a separate video where I explain dependency injection best practices in Spring Boot. Instead, we are going to use constructor injection, which is now the preferred approach. Let's generate a constructor for our customer service class that takes customer repository as a parameter. Right-click inside the class, create generate, choose constructor. Select the customer repository field. Click OK. This will generate a constructor. By doing this, Spring will automatically inject the customer repository when it creates an instance of customer service. Now, let's add method to handle our business logic. First, let's get all the customers from the database. I'm going to create a new public method in the customer service class. The return type is list. I'll name it get all customers. This method fetches all the customers from the database and returns them. Inside the method, I will call the find method from our customer repository. Next, let's create a method to find a customer by their ID. I will create another public method. It returns an optional customer. I will name it find by ID. The method accepts an ID of type long. Inside, we will call the find by ID method from our customer repository and pass the ID. Spring Data JPA makes it extremely easy to query the database by ID. Now, it's time to save the customer to the database. I will create a new public method. It returns a customer object. I will name it save. The method accepts a customer object as a parameter. Inside, we will call the save method from our customer repository and pass the customer. Finally, let's add a method to delete our customer from the database. I will create a new public method. It returns nothing, so void. I will name it delete by ID. This method accepts an ID of type long, which is the ID of the customer we want to delete. Inside, we will call delete by ID method from our customer repository and pass the ID. So, our service layer is ready with the methods to handle the business logic for CRUD operations. Next, we will focus on the controller layer. In the model view controller or MVC architecture, the controller is a key part. MVC is a design pattern that splits an application into three connected pieces: the model, the view, and the controller. This separation helps us manage complexity and make the app more scalable and easier to maintain. First, the model represents the data and business logic of our application. In our case, this includes the entity classes and the repository layer and the service layer combined. The model handles data management, business rules, and interactions with the database. Next, the controller handles HTTP request from the client. It processes the user input, calls a write method in the service layer, and returns the appropriate response. The controller acts as a bridge between the view and the model, making sure that user actions are correctly understood and handled by the application. Finally, the view is the presentation layer, the part users see and interact with. This could be HTML page rendered by the server, which includes data sent from the controller. We are using Thymeleaf to handle the view layer. This layer architecture ensures a clear separation of concerns. Each layer has its own job, making our application modular, scalable, and easy to maintain. Back to the IDE. We have already created the controller. This is our home controller. The home method handles a GET request that comes from the root URL. Let's create new methods to handle other HTTP requests. Since we are creating CRUD application, we need methods for creating or saving data, getting data from the database and showing it in the view, updating the data, and deleting the data. In our home method, I am going to get all the customers from the database and display them using our home.html. We will use our customer service. This service will interact our customer repository to fetch data from the database and return it to the controller. So, we need to inject the customer service dependency here. Let's do that. I am creating a private field. I will make it final. Its type of customer service and I will name it customer service. Now, we need to inject it using constructor injection. I will generate a new constructor, generate constructor, select the customer service field, click OK. Now, inside our home controller, let's fetch all the data from the database. I will call customer service.getAllCustomers and save it to a customer list. Now, we need to pass this list to our view. Use the model object, add an attribute, give the name of the attribute. Let's say customer list, provide the variable name which is customer list. We don't need this message here anymore. Let's remove it. Now in home.html, we don't have the message anymore. Let's create a table. Inside table tag, add a t-head. Inside t-head, add a tr. For table row, we have columns for our first name, last name, email, and phone number. Now we need the table body. Add a t-body. Inside t-body, add a row. This row will be generated automatically based on the number of the customers. So we need to loop through the customers list. In Thymeleaf, we can use th:(each dialect to loop through the data. In the tier tag, add th:(each equals customers list and save it to the customer. Now it will loop through all the customers we get from the database and store each one in the customer variable. We can now use this customer object to access the data. Inside the row, we will create columns using td. In each td, we will use th text to display the data. For the first column, we will display customer.firstname. Let's copy this line and paste it for the other field. And update the field name, last name, customer email and phone. Now let's restart the server and check if we can get the data. Refreshing the page, we don't have any data showing. Let's add customer and check if we can successfully render the data on the home page. We have not created the customer save functionality yet. So for the time being, I'm going to manually add customer data to the database so that we can view it on the home page. Opening our database tool, here is our schema. This is our customer table. I will select this table and click on the table icon to edit the data. It opens the table. From this window, we can add or edit data directly in our MySQL database. Collapse this database tool. Let's add our customer data. Click on the plus icon to add a new row. In this row, we can add our customer data. Entering email address, first name, last name, giving a dummy phone number. Now save the data by clicking on the save icon. Our data is saved. Now back to the browser, refresh the page. Here we have this customer data. Now it looks a bit plain. Let's make it look better. For styling, I'm going to use Tailwind CSS. Let's go to tailwindcss.com. Navigate to the docs section. Here are the ways we can integrate Tailwind into our project. Since this tutorial is not about styling a website, I am focusing on the CRUD functionality of our Spring Boot project. I am going to go with the bare minimum. So I am going to use the CDN. Here is the HTML code showing how we can use CDN. We need to include this script tag with the source to Tailwind CSS in our project. Let's copy the script. In our home.html page, in the head section, I will add the script. Now we will stylize the page. To do this, I am going to use some predefined components by Tailwind CSS that are available for free. Back to the browser, go to the components menu. Let's browse the components. Let's see which component we can use. For our page layout, let's check stack layouts. Let's use this dark navy with white page header layout. I think this is simple and will serve our purpose. Click on code. Here is the HTML code for this layout style. Copy this. Back to the IDE in home.html. Let's remove the table for the time being and paste the code. It provides some instructions. We need to add this hfull and bggray100 class to the HTML tag. And in the body, we need to give the h-full class. Let's do this. Scrolling up, paste the classes into our HTML tag. Then copy the class for the body tag and paste it into our body tag. Now let's check this in action. Run the application. Refresh the page. Okay, our page is looking beautiful. Let's do some cleanup. I don't need this drop down menu. I don't even need the avatar or bell icons. Let's clean up our HTML. Here inside this main section, we will put our content. We will do that in a minute. Scrolling up, here we do not need this mobile menu. Let's remove it. Also, no need for this mobile menu button. Removing the profile drop down. This is the notification section. We don't need that. Actually, we can remove this entire div here. Then here we have our menu links. Let's change the URL of one of our menu items to the root URL. This is the first menu item, dashboard. Let's change the URL to the root. In Thymeleaf, we use th:/href. Then add curly braces and provide the URL. Now let's check the page. Restart the server. Refresh the page. Our unnecessary items are removed. And also this dashboard link now points to the home page. Now we'll display the customer data here. Back to the IDE, minimize the console, scrolling down. Here is our main content section. We will put the table with the customer data here. Again creating the table, then table head, table row, table header column, our customer ID, then we have first name, last name, and email and phone number. Now the table body. Table row, we need to loop through the customer list, th:, each. We will iterate through the customer list and save it to the customer object. Inside this row, we will create table columns, td. First column is id, so th:, text equal $, curly braces, customer.id. Next column, let's copy this line and paste it 5 times. This column is for the first name, next column is for last name, then we have email, and finally phone. Let's check how it looks in the browser. Restart the server, refresh the page. Our table is already taking shape. Let's add a little bit styling so that it looks more beautiful. In the table tag, add the class table-auto and w-full for full width table. Styling the table head, providing gray background color, text color is white, and make it uppercase. Now change the style of the table header columns, adding the horizontal padding of 6, top and bottom padding of 3, centering the text. Copy this whole class and paste it into the other table header columns. Okay, now styling the table data. I want the background of each row to be white, adding the bottom border. For the table column, adding horizontal padding of 6, vertical padding of 5, and centering the text. Copy the whole class and now paste it on the other table columns. Now let's check the final result of the styling. Restart the server, refresh the page. Now this table looks cool. Now we will create a form for new customer entry. At the top, I will add a link to the form for adding a new customer. Let's do it. In the home.html page, before the table, I will add a link. Our URL is context relative, so to support that, we need to use Thymeleaf dialects for declaring URLs. We need to use th:/href. Here, we will use Thymeleaf link expression. We can do this using add, then curly bracket, then specify the endpoint. In our case, it's create. The text of the anchor tag is add new. Let's add some style to this link. Add the class attribute, give it a blue background, medium font weight, horizontal padding of 3, vertical padding of 2, making the corners rounded. Set the text size to small, text color white. Make the link display as inline block. Add a bottom margin of 5. When hovered, darken the blue background to 700. Let's check it in the browser. Our link looks great. Clicking it, it's showing a white level error. Status code is 404 and that is not found. We did not configure our application to handle this create endpoint. That's why it's showing this error. Let's do that. Back to the IDE, opening the home controller. Here I am going to add a get mapping for handling create. Create a public method. It returns a string. Name it create. It accepts a model parameter. It returns the name of the HTML page that will render the view, which is create. Let's create our HTML page. In the template folder, create a new HTML file. Name it create.html. We will add a form in this create.html page. This page will have similar style as home.html. So let's copy the HTML code from home.html. Opening home.html, select all the code, copy and paste it into the create.html. Let's do some cleanup here. This is our main content section. Remove the table. Remove the link as well. Here we will add a form. For styling the form, I am going to use a Tailwind CSS component. From the component list, let's see if we can find anything for our form. In the page sections category, we have a contact section. I think this form is good fit for our project. This form has inputs for first name, last name, email and phone number. Let's use this. Check the code, copy all of the code, paste it into our create.html page. Now let's do some modification and cleanups. Change the title text to add new customer. We do not need this paragraph, so let's remove it. Then set up form action. Here we will provide our form processing URL. We need to use the Thymeleaf dialect to declare the URL. Add th : then action. Set it equal to add curly bracket, then save. The method is post. Use th : method. Check now how it looks in the browser. Starting the server and navigating to our application's create page, refreshing. We now have this beautiful page with the form. I need to do some cleanup on this form. I don't need this company field, the message box, or this extra text here. Also, I want to change the page title. Back to the IDE, minimizing the console and scrolling up to the title page. Let's change it to add customer. Scrolling down to our form, this section is the first name, then we have the last name, and then the company field, which we don't need. Let's remove it. Next is the email field, and then the phone number field. Actually, I am going to remove the existing phone field and recreate it. I will copy the code from the email field and paste it below. Now I will change the label from email to phone. Update the input type to text and set both the name and ID to phone. We don't need this autocomplete attribute, so I will remove it. Scrolling down further, there's a message box and some extra text. We don't need them. Let's remove. Now let's check how it looks in the browser. Restarting the server, opening the browser and refreshing the page. The page title has changed, the form title is updated, and we only have the necessary fields now. The form looks much cleaner. Now it's time to process the submitted form data. Before creating the method to save the form data, we need to tell the form which object we are processing. Since we are submitting customer information, we will define this in the form using Thymeleaf's object binding. In this form tag, I will specify the object as customer. We will pass this object from our controller using a model attribute. Next, we need to update the form fields. Currently, they have name and ID attributes, but we need to bind them to our object properties. We can do this easily using Thymeleaf's field binding. For the first name field, removing these name and ID attributes, replace it with Thymeleaf field that points to the customer first name. We can do this using th, then field, then $, and here we need to define that this is our customer.firstname. This way, Thymeleaf will automatically add the necessary input attributes for processing the form data. I will also update the for attribute in the label to match the field name. I will repeat this process for the last name, email and phone fields, binding each to the corresponding property in the customer object and update their labels. Here this is last name, removing this name and ID attribute, then th : field, this is our customer dot last name. Also update the for of the label. Then there is our email, th field equals customer.email, and finally we have this phone number, removing this name and ID attributes and th : field, this is our customer.phone. Let's restart the server and check it in the browser. Refreshing the page. We are getting a 500 internal server error. What's going on? Checking the console. The exception message says neither binding result nor plain target object for bin name customer available as request attribute. So what's happening here? We have bound the customer object in the form, but our page doesn't know how to get this object yet. We need to declare it in the controller method. Opening the home controller, and in the create method, we will instantiate a new customer object and add it to the model attribute. Starting the server again and checking the browser, refreshing, still getting the error. Let's double check. Reviewing the controller method, everything seems okay. Maybe there's a typo in our form fields. I'll double check the fields name to ensure they match the properties in our customer class. Looking at the form, first name looks fine, last name is correct, email seems good. Aha! Here is a typo in the phone field. Let's fix it, replacing this customer with our proper spelling. Restarting the server and refreshing the page. Now it's displaying correctly. Right click on this page and select inspect. Let's resize the window to see better. Looking at the input field for the first name, I can see that Thymeleaf has added the name and ID attribute automatically along with an empty value attribute. Checking the last name field, Thymeleaf has done the same. Everything looks good now and our form is properly set up to process customer data. Great! We have cleaned up the form, fixed the errors and ensured it's ready for data submission. Now it's time to create a method in the controller to handle form submission. Opening the home controller, our form will be submitted to the save endpoint. So in the home controller, we need a post mapping to handle the save request. Creating a public method, return type of string and name is save. It accepts model attribute of type customer named customer. This method also accepts a model parameter. Inside the method, I will use customer service to save the data by calling the save method and passing the customer object. After saving the data, it will redirect to the home page. I will do this by returning string, then redirect, colon, and the URL where it needs to be redirected. That is our root. Now let's see it in action. Starting the server, we are on the home page. We have only one customer data here. Clicking on this add new button, our customer entry forms open. Here I fill out the form. First name Jane, last name Doe, email address jane@doe.com, phone number, adding a dummy phone number. Now I will submit the form. Wait, we need to change the level of this submit button. It's not descriptive enough. Let's change it first. Opening create.html page, searching for the submit button. Here it is. Here the text of this button. I'll change it to submit for clarity. Restarting the server, opening the browser and refresh the page. Now our button label is changed. Let's fill the form again. First name Jane, last name is Doe, email jane@doe.com and adding a dummy phone number and submit. Our data is saved. You can see our new data displayed here. Again, add a new customer. This time I won't fill out the form. I'll submit an empty form. Submitting, it redirects to the home page and a new row is added to the table. But the first name, last name, email and phone numbers are empty. But this should not be the case. We should not be able to submit the form without any data. And if the user tries to do this, we should provide feedback with an error message. So we'll add validation here. We need to add validation rules in the customer entity class. Opening our customer entity, here all the necessary fields are defined. We'll define our validation rules. For the first name, it should not be empty. For this, I need to add not empty annotation and provide the error message. First name is required. We can also add multiple rules for each field. For example, if our first name has to be at least 5 characters long, we will use size annotation. Set the minimum length of 5 and provide the error message. First name should be at least 5 characters long. Then our last name will have the same rules, copying the validation annotations from the first name and paste them before the last name field, updating the message accordingly. Then for the email, it must not be empty, so we'll use not empty with the message email is required. To ensure it's a valid email, we'll add the email annotation with a message, please enter a valid email address. For the phone, I'm not giving any validation rules. Now we have provided the necessary validation rules. Next, we need to catch the validation error and provide the necessary feedback. Our controller is responsible for this. Opening home controller. In the save method, we have to add another parameter, binding result, named binding result. Let's break the method parameters into multiple lines for better readability. Before saving the data, we need to check the errors from binding result. If binding result has errors, then we return the create.html page. Now, in the create.html page, we need to display the error message. This is our first name input field. After this, I will add a div that will show if there is any error in the first name. We can achieve that using th if dialect, and we will use hash fields.hasErrors. Then I am checking the errors for the first name. If it has an error, we'll display the error message using th:/errors, which will show the message we provide in the validation rule. We will reference this field using star, then curly braces, first name. In Thymeleaf, the star and curly braces expression is used to indicate that the expression is relative to the current form backing object, in our case, the customer. Now, I will add some style to this container. Give it a red text, make the font size small, provide a top margin of 1. Let's copy the entire div section and paste it after the last name field, updating the variables to check for the last name errors and display the corresponding message. We'll repeat this for the email field. For the phone number, even though we did not set any validation rule, I'll prepare the error handling in case we add rules later. Now let's start the project. Refreshing the page, let's submit a form again without filling out. Here we are getting a white label error saying 500 internal server error. Let's check the console to see what's happening. It shows an error about constant violation because we submitted blank data. It's showing the error properly in the console but not showing the create form with messages. Let's check the save method. Here we are binding the result and checking if there is any error. If there is, we are returning this create page. Here we have missed an important annotation. To enable Spring Boot to validate the customer object, before the model attribute, we need to add valid annotation. Now let's restart the server, back to the browser, refresh the form and submit. This time it's showing the error feedback. Now filling the first name and last name and submit. This time we get different error message. The first name field is okay. There is an error in the email field. Email is required. And for the last name, we provided a name that is less than 5 characters. So it's showing that error. Now let's try to save the customer with valid data. First name, that is my first name. Then my last name, my email, leaving the phone number blank and submit. New customer is added. Now let's give a feedback message. When customer is successfully created, I want to show success message at the top of the table. To do this, in our save method, we need to add another parameter called redirect attributes. After the customer is saved, we will add a success message using redirect attributes dot add flash attribute. Then provide the name of the attribute. In my case, I'm going to name it message and then provide the message. Customer created successfully. Finally, it will redirect to the home page. In home.html, scrolling up, before the add new customer button, I will add a div that will be visible if we have flash message. We'll use th if to check if there is a message. Styling the element, make the background light green, add a border with green color, solid border, bottom margin of 5, padding of 2, rounded border, make the text dark green. Inside this div, I will add a paragraph tag that will hold our message using th text with the variable message. Restarting the server, refreshing the page, clicking add new, creating a new user, first name, enter a name, entering a last name, enter a dummy email address and a dummy phone number. Submit. We have an error. We need our user's last name to be at least 5 characters long. Let's update it and submit. Our customer is added. Here is the success message. You can see we have two user data with the same values. That's because I was testing with the same values which I did not include in this video clip. To prevent adding data with the same values, we need to do another validation. But that's a lot of work and is out of the scope of this video. I have another dedicated video on data validation in Spring Boot. Please check that if you want to learn more. Now let's implement the update and delete feature. I am going to add a new column with two buttons for the delete and update actions. In our home.html, I am going to add another table header column. I'll leave it blank. In the table body, I'll add an additional table column after the phone number. So let's copy the existing TT element and paste it, removing the text inside this new column to keep it empty. Inside this TD, I'm going to add links for the edit and delete operation. First, the edit link. I am adding an anchor tag using th:/href. I will set the URL to customer / then curly bracket id /edit. These curly brackets id is a path variable that will be dynamically replaced with the customer id. To tell Thymeleaf how to get the value of this path variable, I will use parentheses after the URL and specify id equals $. This will be our customer.id. This way, the link will point to the correct customer's edit page. I will style the link, background color blue, medium font weight. On hover, darken the blue background. Horizontal padding of 3, vertical padding 2, rounded corners, small text size and text color white. The link text will be edit. Now the delete button. I'll copy the edit link and paste it below. For the delete URL, it will be customer, then the path variable id and delete. I'll change the button background color to red and adjust the hover effect accordingly. The link text will be delete. Starting the server and refreshing the page. Now we have two buttons for edit and delete operations. If we click this edit button, we'll see an error because we have not defined any endpoint in our controller for this operation yet. Let's fix that. In the home controller, after the save method, I'll create a method for showing the update form. I'll add a get mapping that handles customer / curly bracket id / edit. Creating a public method that returns a string. I'll name it edit. It accepts a path variable of type long, name it id and model parameter. Inside this method, I'll fetch the customer from the database by id using customer service.findById, provide our customer id. This return optional. So, or else, if customer is not present, then it will be null. Add the customer as a model attribute named customer. Return the view name, which is our customer entry form on the create.html page. Starting the server and refreshing the page. Now, when we click this edit button, it opens the customer form and the input fields are filled with the customer's data. Here at the top, we can see some unwanted text. Let's check where it's coming from. Opening create.html. I will search for the text. This is our text. Let's remove it. I think this text also exists in our home.html page. Let's remove it there as well. Restarting the server. Now the unwanted text is gone and the form is populated with the customer's data. We need to make some modification to this form. Opening create.html. When we submit the edited form, Spring needs to know the ID of the customer. That's how it knows which entry to update. In case of a new customer, the ID will be 0 or null. For editing, it will be customer's actual ID. To handle this, I will add a hidden input field in the form for the customer ID. This field uses th field, then our customer ID. Since the ID is not something that the user needs to modify, it's better to keep it hidden to avoid cluttering the form. Now, when the form is submitted to the save method, if the customer ID is 0 or null, Spring knows it's a new entry and will create it. If the ID is not 0, Spring identifies that it needs to update the existing entry. Restarting the server and opening the page. Let's edit customer's data. I'm modifying the last name and submit. The customer has saved successfully, and here is our updated customer data. We also have an empty customer data row. Let's edit this one. I'll fill the first name, last name, email address and phone number. Then submit. We get an error in the last name field. Our last name is less than 5 characters. Let's adjust the validation rule. Opening the customer entity class. I will update the minimum size of first name to 3 characters, updating the message, and also update the size of the last name is 3 characters and update the message. Restarting the server, back to the home page. I will edit the customer again. This time I will fill the form with valid data and submit it. So our data is saved successfully. Now let's implement the delete operation. When the delete button is clicked, I want the corresponding customer data to be deleted. Let's do this. Back to the ID, minimizing the console and opening the home controller. After the edit method, I am adding a new method to handle the delete operation. We need get mapping. The endpoint is customer / then the path variable ID / delete. Creating a public method named delete that accepts the path variable long ID. We also need redirect attributes as a parameter since we will show a flash message after the operation. Inside the method for delete operation, we need to call customer service.delete by ID. Pass the ID here. Then I will provide a flash message. Redirect attributes dot add flash attribute. The attribute name is message and the message is customer deleted successfully. Finally, I will return redirect to the home page. Now let's start the server. Our server has started. Opening the page, this is our customer list. Let's delete one of them. I'm going to delete this customer. Clicking delete. So the customer was deleted successfully. Let's check the data. We no longer have the customer in the table. Now the final task. It's time to implement the view for a single customer data. In the home controller, I need a method to process and display individual customer data. Creating a get mapping with the URL endpoint customer / our path variable ID. Creating a public method named show that accepts the path variable long ID and a model parameter. Inside this method, I will query the customer by ID using customer service.find by ID. Pass the ID here. If the customer is present, I will add to the model attribute with the name customer. Finally, I will return the name of the view that will display the customer data, which is show. Now we need to create a new HTML page to show this data. Expanding the sidebar, inside the template folder, creating a new HTML file named show.html. I'll copy everything from home.html and paste it into the show.html. Now let's do some cleanup. Closing the sidebar and scrolling up. In this page, I don't need the message at the top, removing it. We also don't need the link for creating a new customer. The table that displays all customers is not needed here, so I'll remove it. Now to display individual customer data, I'll create a new table, adding class for styling, making it table auto and setting the weight to full. Inside the table, I will display the data. Creating a table row. In the table header, adding a cell for ID, adding class attribute to make the text uppercase. Add a border, align text to the left and add horizontal padding. Then in the table data cell, I will show the customer's ID. Th text $, curly braces, customer.id. Adding class attributes for horizontal and vertical padding. Add a border. For the other customer data, I will follow a similar structure, copying the entire table row and pasting it below several times. Making the necessary modifications. Second row is for first name, displaying customer.firstname. Third row is for last name, displaying customer.lastname. Fourth row for email, so customer.email. And finally, the fifth row for phone, displaying customer.phone. Everything seems okay now. Let's start the server. This is our home page. In the table, I need a button to link to the individual customer's data. Back to the IDE. In home.html, I will add the button. Here is other edit and delete button. I'll copy an existing link and paste it before the others. Updating the href to point to customers/ID and changing the background color to green. I will adjust the hover color and set link text to show. Restarting the server. Refreshing the page. Here is the show button. Clicking it, we now have the individual customer data displayed. Let's add a bit more styling. Back in the IDE, in show.html, I will style the table headers to have a darker background and white text. I'll copy this styling to the other headers. For the table data cell, I will set the background color to white and apply to all of them. Restarting the server and refreshing the page. Now we have the customer data displayed nicely. I would like to make another update. Currently, the page title shows dashboard. I want to update this to show the customer's name. Let me show you something else. Back to the home page. Clicking on edit for a customer, the page title says add customer. We need to modify these as well. If we are editing customer's information, it should display the customer's name. Otherwise, it should say add new customer. Let's do this. In show.html, I'll remove the page title, dashboard. I will replace it with customer's full name. So, th:\text, curly bracket, customer.firstname, then concate it with a blank space and again concate with customer.lastname. Now in create.html page, we need to change the page title as well. I will set the text based on whether we are adding a new customer or editing an existing one. So how can we detect if we are editing or creating a new customer? The answer lies in the customer ID. In the create method of the home controller, we instantiate a new customer with a null ID. In the edit method, we fetch the customer from the database, so the ID is not null. So in create.html, I will check if the customer ID is null. If it is, the text will be add new customer. Otherwise, it will be edit followed by a space, then concate with customer.firstname, again concate with a blank space. After that, concate with customer.lastname. Copying the expression and I will paste it to the form title. Scrolling down, here is our form title. Let's remove this text, moving to the next line, and here paste this expression. Now start the server and refreshing the page. Let's check customer's data. The page title now shows the customer's full name. Perfect. Back to the home page. Let's click edit for this customer. Here we need space between the two parts of the name. Let's fix it. Opening create.html file. Here is our expression. Here we need to put the space. Search for another. Here it is. Put the space between the name parts. Now restart the server. Now everything is showing correctly. Back to the home page. Let's view these customers. Here, would not it be great if we could upload the customer's photo while creating or updating their entry and display it here? Well, we'll learn how to do that in my next video. To watch more, click on the video that appears on the screen. See you in the next video. Bye bye.